Hello, everyone. My name is Mike Atenkorwil. I'm here to present one topic in electrical power, that is understanding single-phase AC motor, uh, the principle and types of AC single-phase motor. So here we are going to explore the fundamental principle and diverse type of AC single-phase AC motor, an essential component in countless everyday application. So we are going to talk about it application in our life and what are the components that are needed in our daily life. How is it important? Single phase motor. So this all about understanding it slowly, and as we know that everything in life, in this modern life, needs electricity. So that's why I've come out with this single phase AC motor to understand deep about it. So here we come to the ubiquity of a single phase motor, the uniqueness of it. How is it unique and how is it applied? So we have fan and ventilation. We know very well that the use of fan and the use of ventilation in this modern life is to keep our homes and also air circulation to be cold. So, and also we are having washing machine. Washing machine, we know it is make our work easy for washing our clothes to be clean. We have kitchen appliance, making kitchen tasks easier. So like blender to mixer, it mix the fruits to be good, to be drinked for drinking. And also we having pumps. We know commonly pumps are used for like moving fluid for irrigation, uh, and also plumbing and more. All this one single phase AC motor are used for that. And here we come to the working principle of one single phase. What are the principles? Here we're having one single phase as to starting winding. Namely, the main phase winding, which is U1 and U2. These are the U1 and the U2. So coming to, and also additional phase winding, which is Z1 and Z2 winding. So all these are the working principle. We have the main winding use a larger surface area of copper wind. Yeah, the different about this diagram down, the difference in the magnitude of the independence of the two winding, these differences in special differences in current cost, total current, which is the sum of the main current vector and the auxiliary current. The main magnetic field generated by the main winding is also different from current with additional magnetic field. The cautions of this. So here we come to why single phase motor need a starting mechanism. We're having zero starting torque. We're having stimulating a rotating field. We're having diverse solution. In zero starting torques, uh, the single phase current creates two equal and opposite magnetic field, effectively canceling out any rotational force at standstill. And we're having auxiliary winding, capacitor, and shading coil are employed to introduce a phase shift. So to make the rotating magnetic field to create it diverse. This fundamental problem has led to various motor design, each with its own starting method. So all of them are not having one starting method. All of them, due to their different of design in design, make them to have different mechanism to work. So here we come to motor capacitor. Motor capacitor integrate creating the phase shift. How does it work? How capacitor work? Capacitor are crucial component in many single phase motor, offering a robust solution to the starting problem. So we said before it needs a starting mechanism. So here capacitor is one of the mechanism that it is used. Auxiliary winding connection. A capacitor is typically connected in series with an auxiliary winding, which is electrically offset from the main winding. So here we come to the phase lead. The capacitor causes the current in the auxiliary winding to lead the voltage, creating a significant phase difference compared to the current in the main winding. Rotating field formation. This phase differences create a personal rotating magnetic, providing the necessary torque to start the motor. That is capacitance. The work of capacitance, how it works, auxiliary winding. So here we come to the shadeful motor. This is one of it. So here we say operational characteristic. What are the operational characteristic of it? A simple copper. It has a simple copper, simply designed. That is a unique design. We're having weak rotation. It has a weak rotation. This delay flux interact with the main flux, inducing a weak rotating magnetic field that starts the motor. Advantages. What are the advantages of shaded fold motor? Highly flexible, extremely low cost, minimum maintenance due to its simple construction. Disadvantages, very low starting torque, poor efficiency, limiting its use to light heavy duty application. It is not applicable, it's not used, applicable to heavy duty use. So these are the limitations. The limitation is very low for efficiency. So that is it. And we come to universal motor. The versatility across AC and DC motor, dual power capability. These are the two different current. We're having AC, which is alternating current, and we're having DC, which is direct current. So here we say the universal motor stand out for its ability to operate on both alternating current, which is AC, and direct current supplies. The series wood design. We're having high starting torque. We're having variable speed. The speed are not the same for AC and DC motor. So it is armature and field winding are connected in series and a configuration that allowed it to maintain the same direction of rotation regardless of current direction. High starting torque offer exceptional starting torque, making it ideal for application requiring immediate power. The speed can be easily controlled by varying the supply voltage, providing flexibility in operation. Here we come to three-phase motor supply, one-phase motor. We know this one is very essential where there is no three-phase, and we need. So here we have operational flexibility. While primary design for three-phase, this motor can be adapted to run on a single phase. The three-phase can work on the single phase supply under a specific condition based on the specific condition. We're having starting challenges. There are some starting challenges that are experienced when we use three-phase on single phase. We're having reduced performance. The performance will not be the same as the three-phase motor. This workaround is often employed in location where three-phase power is unavailable. But the robust characteristic of a three-phase motor are still desired. If there's a need of three-phase motor, single-phase motor, three-phase motor, then we can use it. Yeah, visualizing the rotating magnetic field, we're having the coil, we're having pulsating flux line, we're having two coil, we're having capacitance. This side we're having capacitance ship rotating, single phase pulsating. We're having phase ship current. The fundamental difference between a simple single phase motor and a self-starting on one lies in the clever manipulation of a magnetic field. All of them depend on the manipulation of the magnetic field. All of this we have in the coil. This one, this side, the single phase fascinating, we have only a single coil. Here we're having two coils. But the difference is about capacitance. This side we're having capacitance, and this one we're having only single phase per setting. So capacitance, we know it is still a little bit current before it totally stops. So this is all about how to create the magnetic field. The real world application and advantages. We're having, before we talk about household appliance. So we said, yeah, the advantages of it on application is that they are used in common household appliance. Like we're having pan, we're having refrigerators, we're having water pump, driving convenient and comfort in our daily life. All of them make our daily life very important. We're having enhanced efficiency, that is advantages. It make the work easy. Capacitor start and capacitor run motor provide superior starting torque and improve power factors, making them ideal for air conditioner, compressor, and large domestic application. We're having portable power, universal motor ability to operate on both AC and DC, coupled with high starting torque, make them indispensable for power tool. Thank you for your time. That's all about it. Thank you.